All right. Now, let's focus more skills on differentiating non-polynomials. Can you all remember what this non-polynomial means? What is a non-polynomial function? Yes? Can you remember what is a non-polynomial function?
Yes.
What? What does it mean? What's the definition of non-polynomial function?
Many to one, right?
So if I've got y equals x to the something, alright, what can the something not be?
Negative. Aha.
Sorry?
Between 0 and 1.
Are you sure it has to be, cannot be, sorry? What was it? Cannot be between what?
0 and 1.
Cannot be between 0 and 1. Alright? Does that mean that 1 is included?
No.
Thank you. So it's all non-fractions. Alright? And it cannot be, can it be negative?
No.
No. So it cannot be negative as well. So here, we're going to look at differentiating function which is not non-polynomial. And you should be able to apply your knowledge of derivative to other non-polynomial functions using the power rule. First, by converting to index form. So you must know your index law, and then solve for specific points on a function with a given gradient using calculus technique. Alright, it's still very skills based. We are going to talk about how to answer worded question next week. Alright, so you must recall when we do a derivative using the power rule x to the power of n, the first derivative is n times x to the power of n minus 1. And we can generalize it if you have a coefficient in front of your x to the power of n. Alright? So you should all remember this, and we can go on to do some examples after we have a chat about these slides. So when functions are not written nicely as polynomials, we should prepare the differentiation by power rule by getting them into a polynomial-like expression in terms of index forms. Alright? So if we've got variables on the denominator, for example, something like 1 over x, we make it into a negative index, which is x to the power of minus 1. Something like this. Alright? Radicals. Let's say we've got 1 over square root of x. That is 1 over x to the power of half and x to the power of minus half. Alright? Now, products of function in year 12, you will learn the product rules. But I will specifically say, no, you should not learn that yet until year 12. You're going to learn to do products of functions by expansion mark for now, alright? The word for now. Okay. Next year, in year 12, you will learn the product rule and the quotient rule for differentiation. But not yet. Let's wait for a while. Alright? Now, here I've shown you if I've got y equals 1 over x, therefore we can write y equals to x to the power of minus 1. And therefore dy dx is, using the power rule, minus x to the power of minus 2. And you can of course rewrite it as that. Alright, depends on whether you're asked to write it as positive index or not. So I will accept both. Same with the next one. That will be x to the power of half, correct? So therefore dy dx is, what would that be? Okay, which is? Thank you. Alright. Either form I'll be happy to accept. I don't mind. Okay? Now, getting to something like this, how would you do it? So you want to find the instantaneous rate of change.
Make the t to the top.
Thank you. So v then equals to rewriting it 3t to the power of 6 plus 2t to the power of minus 1 minus 3, t, oh gee, that's pretty bad writing. Let me rewrite that properly. 3t squared plus 8. So can you do the dv/dt for me, please? I think I got it right now. All right, this is my answer, minus 23. So, when you do something like this, let's concentrate on this. This is plus, all right? So you bring minus 1 down, minus 1 times 2, you've got minus 2. Minus 1 take away 1, minus 3. Minus 2. So therefore minus 2t to the power of minus 2. Minus 2, that's 6. Oh! Gee, that's pretty bad of me. That has to be 6. My fault. 6. That has to be 6. Oops. I've lost it. I don't know what happened. I must have pressed the wrong button. I've lost it completely. Doesn't matter. I'll rewrite that out in a few minutes. So, dv/dt equals to 18 t to the power of 5 minus 2 to the power of t squared plus 6 to the power of t cubed. All right? After a while, you get used to it, but I will ask all of you to write it out, all right? You write it out as v equals to 3t to the power of 6 plus 2t to the power of minus 1 minus 3t to the power of minus 2 plus 8, all right? So therefore, dv/dt at t equals to minus 1 equals to 18 minus 1 to the power of 5 plus 2 minus 1 square plus 6 minus 1 cube. All right, that's minus. That should be minus. So therefore, that's minus 18 minus 2 minus 6, which is minus 26. All right, my fault was a minus 23. All right, next. What about this? Determine the gradient of the tangent to the curve at x equals to 2. So rewrite it. Please rewrite it. So y is therefore equals to x to the power of 3 over 2. Am I right? Change it to radicals. Plus x squared over 4. So can you do dy dx, please? All right. The answer, you should have a cert in there somewhere. Yeah, you should have a cert. If you want, rationalize the cert, which will become 3 square root of 2 over 4 plus 1. All right. Of course, if you like, you can even put it in this form.
Sir, it's not a negative half, it's just a half. So you don't put it at the bottom.
Oh, sorry, it's my fault. Yes. Half. I don't know why I did that. Yes, of course it's not half. Ooh, pretty bad. So it's my fault. So it's pretty much 3 over 2, square root of 2 plus 1. That's all. I have no idea why I thought. I wrote half there and I actually rewrite it the other way. Doesn't matter. All right, next one. Here. Oh, sorry, go back. Yes? What's up? What have I done wrong in that? So, here, 3 over 2. 3 over 2 take 1. That becomes half. Take the square down. That is 2 over 4, which is 1 over 2. 2 minus 1 is x. That's all. Alright? For the next one, what I would like all of you to think about is expanding first. Alright? You need to be able to do your expansion. Alright? Do your expansion. That expansion. Alright, I'm not going to, probably I'm going to get rid of that. I think you should be able to do it without that. Alright, expand it. And then do your differentiation and then find the coordinates. You can expand it. The second number is a little bit more complicated as such, but you should be able to work it out, all right? I would expect all of you to be able to work out as a fraction. Now at this stage, when you do this question in the exam, I will expect all of you to expand it, all right? So if I've got it right, if, this is the answer. One of them is 0, minus 4, the other one is minus 8 over 3, 220 over 27. All right? You will be expected to do this in the non-calc section, all right? Yes, you are expected to do the non-calc. This one is straightforward enough for you to do it in the non-calc. All right, one last example for you. Yep, sure. I'll give you a few minutes and then we'll do the last example. So the complication is you need to be able to substitute your x in, all right? So you know x is minus 8 over 3. So that's minus 8 over 3. So square of this is minus 8 over 3 all square, so 64 over 9. And then the rest, just substitute in. And then you've got two negative numbers. Negative times negative will give you positive. And finally, the last example. Can you try doing this, please? How would you determine the equation of the tangent to the curve at x equals to 1? So, hey, I know it is easy. Rewrite it straight away. Y equals to x to the power of half, x to the power of 3 over 2 minus x to the power of minus 1. Alright? Expanding it, x to the power of 3 over 4 minus x to the power of minus half. Correct? Now you can do your differentiation.
Did you add the one? Isn't it just one?
Index law, remember your index law? Oh, it's add. What am I doing? This is adding and I'm multiplying, and this is... You add it, not... You add it, of course. Half plus 3 over 2 is 2. Of course you add it. You need to know your index law. All right. Once you've done that, you should be able to find the derivative, which is dy dx equals 2x plus x to the power of minus 3 over 2. Minus half minus 1 is minus 3 over 2. Therefore, it's 2x plus 1 over square root of x cubed.
So
Yep.
why isn't, when you get the derivative, why isn't it 2x plus a half x to the negative derivative? Why
Which one?
So the x to the negative derivative, shouldn't that end be in front of you?
This one, 2x minus 1 minus 1 minus half. Of course. Of course it is half. What am I thinking? I have even no idea. So there's 2 here. So there's 2. That should be 2.5, which is 5 over 2. All right. So it's my fault. Five over 2. So it's 5x over 2 minus 5 over 2. Or y equals to 2. 5x minus 5. All right? That's how you do it, and I know it's very easy to make a mistake. I was just concentrating on the power. So these are all, like I say, skills based. You should be able to do it like accurately and with a little bit less time. So you need to be able to do your skills properly. I'm going to stop here.